A because it's on the lower bound. But it's the same idea. You're just going to replace it, and then instead of using B, use A because it's the lower one, and you're doing negative infinity instead of positive infinity. So that would be, oh, I don't have a picture of that, but that would just be like an asymptote on the left. This example is probably like the most annoying is when you're doing negative infinity to infinity. So that one is like a double whammy because you kind of have to do two limits, which is annoying. It can be. So the way you do that one is you pick a rando number between negative infinity and infinity. You get to pick basically your favorite number ever. You know, do you know what my favorite number is? 0. Exactly. I always do 0. But if you want to do like, my favorite number's 12, you can do 12 if you want. It'll still work. But if you're more of a normal person, I would use 0, sometimes 1, depending on the problem. Okay, so that's an example where it's like you're integrating, but the asymptote's like in between your like infinite graph, basically. So it's really not too different from the way we solve a lot of these. So like here you should look at that and be like, oh, infinity, this is improper. So what you do to rewrite it is you write the limit, and because it's in the upper bound, I do b approaches infinity, and you replace it from 0 to b, e, I should keep this the same, e to the negative 3x dx. And if you're in BC next year, they're a little psycho about the notation. I'm assuming colleges will be too as well, but they're like psycho about making sure you write it in the limit notation. So the only annoying part is now you're going to have to integrate and then bring down the limit each time. So once you like accept that as part of life, you kind of get over it pretty fast. So you're going to go limit b goes to infinity, and then you're going to integrate e to the negative 3x. If you need to do u substitution, do it. Otherwise, I think you guys are pretty good with just knowing it's negative 3/2, or negative 1/3, sorry. Negative 1/3 because of the chain rule. Or you could do a u sub. So, and then the way you would write it is from 0 to b. So nothing's really changed except now you have this like b thing and the limit in front. So now what you're going to do is you're going to do the plugging in thing, just like as if those were two numbers. And you got to write the limit thing again, so it drives you insane. So you're going to go limit as b goes to infinity, and you're going to basically plug in b. So negative 1/3 e to the negative 3b. And then minus negative 1/3 e to negative 3 times 0. So it's like just like how you normally plug stuff in. Again, the limit is still, why isn't that showing up? Oh, never mind. Okay. So the limit's still hanging on until you evaluate it. So like for my brain, I needed to like kind of mess with this a little bit for myself to like remember how to do these. Like for example, the negative exponent, I'm kind of like, what is that about, you know? So I usually will write it like negative 3, and then I'll put e to the 3b on the denominator, because then it'll like help me think about what the limit value is. You know what I'm saying? And then this guy, the second number is usually like some rando like number or whatever. So like this one, what is that? 1, so then positive 1/3, right? So this would be plus 1/3. And then the grand finale is like when you actually evaluate the limit. So like clean it up so your brain can handle it. And then you take b to infinity. So b is on the denominator. That's going to go close to 0. So basically you get 0 plus 1/3. So your answer is 1/3. And the word they use for this is called convergent. It means it like approaches an actual value. So the two choices between like when you're solving these, it's either going to be convergent, which is like you get a number, or it's going to be divergent, which means you get like a type of infinity for your answer. So that's pretty much it. Any questions? Okay. This is the one where it's like, oh, because there's like a double one, you know? So you have to like, this is the one where you get to pick your favorite number, basically. So you're going to split it up into 2 different limits, which is like, you know, it'll be fine though. We'll be okay. So I'm going to do the lower one first. So obviously there's an infinity in there. I'm going to use A because I always do A and B just to be consistent. You can't use X. That's the only one you can't use. So you're going to go limit as A approaches negative infinity. And then you have the integral. And then your A is like what replaced the infinity part or whatever. And we're going to split this into 2 integrals because you can't do like 2 limits on one integral. Do you know what I'm saying? So that's why we have to split it up. So again, you get to pick your favorite number. My favorite number, probably like 90% of the time, is 0. I'll do green. So my favorite number is 0. You get to pick what you want. And then what you're going to do is then, what just happened? This thing's being a little nuts. I don't like when dx is on the numerator. It makes me nervous. You guys know all my little quirks by now, so we're just going to roll with that. Okay, so now we go from, now I'm going to do the top infinity, you know. So I'm going to go limit, don't do A again, it's going to be B. Because you have to like keep track of like where everything is. And then you're going to do an integral, and then whatever you pick for your upper bound on the other one, it has to be the same in the other kind, because you have to like pick up where you left off, kind of, is a way to think about it. So that one is going to go to B, and then you integrate like the same equation, basically. So now it's just normal integrals, but you have to keep writing limit over and over. So it'll drive you insane, you know. A to negative infinity. Do you know what this guy is? Inverse tangent or arctangent, yep. Inverse tangent from A to 0 plus, I wonder what the next one is. Oh wait, it's the exact same. That's the only silver lining. But it is a lot of writing, so whatever. Okay, so then to get your bearings, like plug in, just like how you would do a normal integral, plug in the upper bound minus plug in the lower bound, but you have to keep writing limit over and over again. So you're going to write limit as A goes to negative infinity, inverse tangent of 0 minus inverse tangent of A plus limit as B goes to positive infinity, inverse tangent of B minus, oh, why did I write plus? That was dumb. Oh no, that is plus. Sorry. Okay, inverse tangent of B minus inverse tangent of 0. And then you're like, oh, trig, ugh, you know. So remember what inverse tangent looks like. So on the BC exam, they almost always have an improper with inverse tangent, just because they really like this curve. So we're just like, okay, we're just going to go with that. So inverse tangent, remember, looks like this. Okay. Do you guys remember where the asymptotes are? What's the asymptote? Does anyone remember? Pi over 2, yep. Pi over 2 and negative pi over 2, right? So this is the inverse tangent graph. So now I'm going to like legit evaluate it. So I'm going to drop the limits after 1,000 years, right? So I'm going to drop the limits because now I'm going to be like evaluating this. Okay? So inverse tangent of 0, that's like just like a number, right? Because like it's just this, right? So maybe I'll put, so this guy, this one's just 0, right? Both of these, actually I might just write it now. Okay, so that's just 0, inverse tangent of 0, because that's a graph, so 0, 0, right? And then minus, and then inverse tangent of A. So now this is where you have to be thinking about like, okay, this is where I'm looking at that limit, right? So as a goes to negative infinity, right, as the curve, it approaches the value negative pi over 2. Okay. So taking a limit of a number is just the number. So that doesn't, this 0, 1 doesn't really do anything. But like this guy, this is where it's like, okay, this is where A is going to negative infinity. So then the next one is the inverse tangent of B. So that one, you're looking at your limit, right? So B is going to infinity. So as it goes to infinity, you're going to a positive pi over 2. And then minus the 0. So this one is how I got to positive, and then this one is the negative. Okay, so then what does this equal? Pi. Oh my gosh, that's so satisfying, isn't it? Pi. Weird. Okay. All right, another one. Okay, 3. Look at a little infinity. Okay. So limit, I'm going to use A because it's on the bottom one. Okay, we're going to 0. Change this to A. We're integrating 5 minus 2x dx. Now you could do a u sub, but it's just an x, you know? So, well, maybe I shouldn't take this for granted here, because does anyone know what the antiderivative is? Yeah, it'll be natural log of this, right? Times negative 1/2, yep. So you could do the u sub with it, but that's the antiderivative. So it's just x in the denominator, so you know it's going to be a natural logger. You know, if it was squared, that'd be a very difficult problem. But like, since it's just x, it's natural log, and then you just have to undo like the chain part of it. If you're not sure, just take the derivative. Take the derivative of it and see if you get the integral back. Oh, but I just dropped my limit. What is wrong with me? You guys, it's so bad. I'm feeling the pink again, so no rhyme or reason. Just going with it. Okay, so now you're going to plug it in. So you're going to plug 0 in, minus. Keep the limit. Drives you insane. So you get negative 1/2 natural log. When you plug 0 in, it's just 5. I'm not keeping the bars around because I'm evaluating it. Do you know what I mean? So like what's the absolute value of 5? 5. Do you know what I'm saying? So I don't do the bars anymore. And then I'm just going to change this to plus a half because it's going to end up being, okay. Okay, so now you're going to do the limit thing again. So this, once you evaluate it, well, this thing's like the, whatever that is, you know, some number, right? And then negative infinity. So natural log, and you're like, what is that? And then you're like, the hand. Remember? Look at the hand. So natural log, I mean, going to infinity. Okay, so it's negative, right? So you're taking the natural log of a super psycho huge number, right? Because it'd be negative. Well, it doesn't even matter because it's the bars, you know, the absolute value. So even if that was a positive infinity or a negative infinity, it's going to give you natural log of super huge number. So if you're doing a natural log of a super huge number, this is just like, this is also really bad notation, by the way. That would give you an infinity, okay? So this would go on forever because like the graph for natural log, you know, is like this thing, you know. So it steadily goes to infinity, not like super fast, but it still goes on forever. So you're like, oh, this random natural log number plus infinity. You know what you say? You say divergent. So instead of saying it equals infinity, they say that's kind of like janky language. You have to use the word divergent. That's what it means. Goes on forever. It doesn't belong like the book series. Do you know what I'm saying? Okay. Yeah.
If you were writing it, can you just like leave the limit and then skip?
Yeah, I honestly wouldn't even write this step. I would just go divergent. Yeah. Yeah. All right. Now this is where things get sass. Your pun? Okay. Isn't 4 sass? That feels normal. Normal problem. Just kidding. What happens at what? 9? What happens at 9? Asymptote. Doesn't exist. Do you see that on the denominator? The denominator equals 0 at 9. So you have to be like looking at that. This is where you pray it's on multiple choice. At least on multiple choice, they're usually nice where they'll put part D is divergent. So you'll be like, oh, like it'll help you like check, you know, to make sure that you know it's improper. But sometimes they don't, or if it's on F or Q, you're kind of like in your own world there. So the way you would write this guy, because 9's the issue. Okay, so once you get to 9, you've got an asymptote. Like if you weren't sure the graph of this, so at 9, there's an asymptote and the graph looks like this. Basically, well, it looks more like, it's like that. So you're going from 1 to 9, but at 9, you're like going down forever. So you're kind of like, oh, jeez. So how do you rewrite that? Because you're not going to do infinity. Like you're going to do the b thing. You're going to do the limit as b goes to, but you're not going to do infinity, okay, because you're approaching 9, okay? So as you're approaching 9, it's different than like finding the area from like, I don't have a good picture of this. Hold on. It's different from finding the area of something like this that goes on forever because you're going to infinity, okay? Like it's a horizontal asymptote. This one, when you hit 9, it's like you're hitting a wall. So the way you're going to set it up is the limit as b goes to 9, but approaches it from the left. So you have to do this guy. And the reason it's the left is because you're going from 1 to 9. So if I was going from like 9 to 15 or whatever, I would be from the right side. You know what I'm saying? So like, since you're coming from the left side of 9, this is why it's got to be a little, like the little negative guy on there. Okay. So you're going to go 1 and then b. I don't like that dx there. It makes me nervous. And just kidding. You know what I'm going to do? I'm going to do this. That's easier from my brain. Because then I don't have to do my u sub. Because you treat this the same thing as if it was x to the negative 1/3. So what I did is just rearranged it, you know. And when I do the antiderivative, rewrite the limit for the 80th time, it's basically I'm going to add 1 to the power, so it'd be 2/3, right? And multiply by the reciprocal from 1 to b. It's like, here, maybe I'll write a little note. It's the same thing as if you were integrating x to the negative 1/3. Do you know what I mean? Or take the derivative of this. You get that back. You know. All right. So then, gotta plug it in. B9 left, and then 3/2 b minus 9 to the 2/3 minus 3/2 what's that, negative 8 to the 2/3. Okay. Oh, I hate those rational exponents. Okay, so now I'm plugging in 9 in. Well, what happens when you plug 9 in? 0, right? 9 minus 9 is 0. Okay, right? And then this guy. Ugh. Okay, so what do I have to do? Cube root it. So I got to cube root it, which is what? Negative 2. Then square it. Positive 4. Right? Yeah. 4 times 3. I'm not going to do this. Times 4. Right? So 6. Negative 6. Makes sense because all the air is below the curve. That's how you know. Okay. Any questions on that? Yeah, that's convergent. Yeah, because it approaches a value. Yeah. Gabe?
For like the 9th, that like you're coming from the left side.
Yeah.
Does it like matter in the end or didn't have that?
In this one it doesn't, but in others it does.
Why?
Because, like, I guess I can't think of one right now, but it matters. It's like if the negative sign mattered, if it's like in a denominator or something. I can't think of something right now, but it does matter. I promise. Let me think, and I'll tell you later. Okay. Yeah. It is a good question. I have to think of it. Okay, this one's easy. This is SAS. SAS. It looks so easy. Where's the SAS happening? 0. Oh, perfect. I love doing 2 integrals. Do you know what I mean? Because 0 is where it's messed up. Do you know what I mean? Okay, it'll be fine. So this graph has a vertical. What would that be looking like? Like this kind of ish. It's a little closer to the axes, but whatever. You get the vibe. Okay. So what I'm going to have to do is 0 is where everything hits the fan. Okay. So I'm going to do limit as b goes to 0 from the left, because I'm integrating from negative 2 to that 0 value. Does that make sense? Okay. So negative 2, I'm going from negative 2 to 0, so I'm approaching it from the left side. Okay. And then we get, I'm going to write x to the negative 3, because then it's like easier in my brain. Now I get another integral. Yay! Oh, wait, it wouldn't be b, it would be a. A approaches 0, because I got to go from 0 to 3 now. Because I did negative 2 to 0, now I go 0 to 3, so now I got to be on the right side. Because I'm doing 0, because asymptote, do you know what I mean? Asymptote there. But then I got to go to, what do they want, 3? Sassafrassin. Okay, so this is how I kind of cheat. Okay, I do the first one and pray it's divergent. Because if it's divergent, it doesn't matter for the second. Do you know what I'm saying? So like what I usually do if I'm given a question like this, I'll just focus on the first one. Because if I get an infinity, then I'm done. Then I'm like, oh, it's divergent. Because what is it? What do I get here? 3? Oh, cool. What's infinity plus 3? Okay. You know what I'm saying? So even negative infinity plus 3. So what I'm going to do is I'm just going to focus on this first one and just pray that it's divergent. And then if it is, then I'm happy. Okay. So, so again, I guess I'll just rewrite this. Okay, so I'm just focusing on this, okay? And antiderivative. So add 1, right? So negative 2 divide by the new power from negative 2 to b. Okay? I don't like negative exponents. They make me nervous and I don't like thinking about them. So I'm just going to rewrite this. So it's negative 1 over 2x squared. Do you know what I mean? Unless you can do negative exponents in your head. Good for you. Yeah. Okay. Is everyone still alive? Okay. You'll say something, right? Okay. All right, so now I'm plugging. Okay, wait, it's minus a negative, so I'm going to write plus. And then 2 times 4. I could have written 8. Whatever. I'm just going to do that. I got another line, kind of. Okay, 0. Now I got to think limit brain. Okay. What's 1 divided by 0.00002? That's what I have to think about. Do you know what I'm saying? Like because if I plug in 0, I'm plugging a number in like super tiny. So it's like, think about it. If you did 1 divided by 1/1000th. Do you know what I'm saying? Wouldn't that be negative 1 times 1,000? So it gives you a big number. Yes, you guys, this is so good. I get a negative infinity, which is what I want. Because like, oh, negative infinity plus a little plus 1/8. Okay, don't care. Because I can just write divergent. This is happy news. So I don't even no need to bother. Okay, so there you go. Yeah.
Where does it be like, when you plug in like negative 0.000?
Yeah. But either way, you're squaring it, so it's positive.
Isn't that where it matters? Like having like the, like my question earlier.
Yes, but I'm trying to think of it where it's like a number. Do you know what I'm saying?
Oh yeah.
Because either way, it's whether you get positive or negative, it's divergent, so that doesn't change anything. But no, I have to think so. No, there's somewhere you get a number. Do you know what I'm saying? Oh yeah, I know. He'll come back.